In this video, we're going to be looking at slope and lines. So mathematicians have developed a useful measure of the steepness of a line called the slope of the line. Slope compares the vertical change, the rise, to the horizontal change, the run, when moving from one fixed point to another along the line. So to calculate the slope of a line, we use a ratio or a fraction that compares the change in y to the corresponding change in x. So this should be something you're familiar with. Slope, change in y over change in x, sometimes called rise over run. And so we do this by finding the difference in the y values over the difference in the x values of two different coordinates, making sure we're consistent in the ordering that we use. Now, a common notation you'll probably end up seeing at some point is using the Greek letter delta, delta y over delta x. Delta just means change in. So I find it a lot easier to just write delta y over delta x instead of the slope formula, as long as you understand what it means. So change in y over change in x. So if we're asked to find the slope of the line passing through each pair of points, we usually use the letter m to represent our slope. So again, order here doesn't matter with the way we put these into the formula, as long as we stay consistent in the way we do it. So for A here, I've got the coordinates -3, -1, and -2, 4. So I'm going to pick a y value to pick first. So I'm going to go ahead and pick 4. And then I'm going to subtract the other y value, which is -1. Now, since I picked 4 for my first y value, I need to pick the corresponding x for the first x value in this. So that would be a -2 minus our other x value of -3. So 4 minus -1 becomes 4 plus 1, which is 5. -2 minus -3 becomes -2 plus 3, which is just 1. And 5 over 1, we know, reduces to just being 5. For B, same idea here. I'm going to pick the second y value again. So I'm going to do -2 minus 4 over, I need the corresponding x value, so that'd be the +2 minus -3. So -2 minus 4 becomes -6. 2 minus -3 becomes 2 plus 3, which is 5. So our slope here would be -6/5. So this is the possibility of what it could look like depending on what your slope is. If you have a positive slope, that means your line is going to rise from left to right. So it's going to go up as we travel from left to right. If you have a negative slope, your line is going to fall from left to right. So we're going to be going down as we move from left to right. Now, if you have a horizontal line, your slope is 0. So again, if we think about this idea of the change in y over change in x, and we think about it, well, the y's aren't changing. It's the same y value all the time. So when we subtract the two y values, you're going to get 0 in the top, no matter what. You might get a number in the bottom, but 0 over anything gives us a slope of 0. Comparing that to our undefined slope, so this is if we have a line that's vertical. So again, thinking about change in y over change in x, well, now my y values are changing. So there's going to be some type of number for the change in the y values. But because our x values aren't changing, it's always the same x coordinate, that means our denominator there's going to be 0 because we're subtracting the same thing. And that's what makes this undefined. The one thing we can't do in math is divide by 0. So since we're not allowed, that's how we have an undefined slope. Moving on to equations of lines. The first one to talk about here is called the point slope form. Now, the way we name these actually tells us what pieces of information the equation gives us. So point slope form is going to be a non-vertical line with slope m that passes through the point, and it looks like this. So y minus y1 is equal to m times the quantity x minus x1. So what does this have? This has a point. That's our point. And it also has a slope. So the naming actually tells us what information that this equation has. It gives us a point and it gives us a slope. So if we want to write an equation in point slope form for the line with slope of 4 that passes through the point, and then we're going to solve it for y. Okay, so they tell us the slope is 4, so our m is 4, and then they give us the point -1, 3. So following my order here, my rule says I do y minus y sub 1, which is my y coordinate of 3, is equal to m, which is 4, times the quantity x minus x sub 1. And my x sub 1 coordinate here is a -1. All right, so this becomes y minus 3 equal to 4. X minus -1 is the same thing as x plus 1. And so this, from here, we're going to solve for y. So we want to get y by itself. We got to start by distributing that 4. So we'll have 4x plus 4. We add the 3 to the other side. We get y equals 4x plus 7. So what we have here is, this is our point slope form. We'll highlight it. This is point slope form, where I can see the point as the coordinate. I can see the slope out front. This one, it turns out, is actually going to be our slope intercept form. So I can still see the slope. That coefficient in front of x is our slope, but that 7 actually ends up being our y-intercept. So here it is, slope-intercept form. Again, naming is important. It's telling you the data. Slope-intercept form, slope m, and the y-intercept b is our y equals mx plus b form. So we can often see this in function notation as well. F of x is equal to mx plus b. Okay, so these are still linear functions, linear equations, right? We can see that, we've seen that before. Y equals mx b plus b, the slope-intercept form, is what we usually use for graphing. Okay, so the point of the y-intercept is what we're going to graph first. It's on the y-axis. So something to consider, that b is actually representing the point 0b. Since it's on the y-axis, it's got an x-coordinate of 0. Once we plot that, then we can use our slope. Okay, so you can write m as a fraction and use that rise over run idea, starting at the point containing the y-intercept. I usually like to draw as many possible points as I can, and then connect the dots from there. So let's say we want to graph this function. F of x is -3 halves x plus 2. So our slope is that coefficient in front of x, and our y-intercept is the coordinate 0, 2. So that's where we're always going to start, is with that y-intercept point. Now, this is where we're going to be careful with slope. So slope is a fraction that's representing that change in y over change in x. Now notice they put the negative out front. What we can actually do is we can move that negative around to different positions. I could instead put it in the numerator, and it reduces to the same thing. I could instead put it in the denominator, and it reduces to the same thing. But from here, we can use this idea of, well, this is the change in y, and I wrote y twice. Let's not do that. Change in y, this is our change in x. So thinking about directionality, okay, so if I start with this one here, I've got a -3 for the change in the y. So y's are negative, that's a downward action. +2 for our change in x, positive changes our x are to the right. So this, in this form, it's telling me to go down 3 and right 2. So I can do that. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. But thinking about the fraction the other way I wrote it, so now we're looking over here. Now I've got a positive change in y, so positive y's go up. I've got a negative change in x. X is negative, go to the left. So this, in this form, it's telling me to go up 3 and left by 2. So I go back to my original y-intercepts. I go up 1, 2, 3 and left 1, 2. Up 1, 2, 3, left 1, 2. And you can see it goes in line with the rest of my points. I did my best to connect the dots and put my arrows at the end. So we saw those kind of weird slopes of the horizontal and the vertical lines. So if a line is horizontal, its slope is 0. So the equation y equals mx plus b becomes y equals b. 0 times x is still going to be 0. So anytime we have a horizontal line, it's going to be a y equals. The way you can think about it is, if you have a horizontal line, it runs into the y-axis. So it has to be a y equals equation to run into the y-axis. Similarly, if we have a vertical line, okay, think about what axis does it run into? It runs into the x-axis. So it's x equals whatever value it is that goes there. So something to keep in mind, Does a vertical line represent a graph of a linear function? The answer here is no. It's not going to pass the vertical line test because every point is actually on that vertical line. So no vertical line could ever represent a linear function. Now we've got one more equation of a line. I don't find this one particularly useful. They call this one general form. It's pretty similar to what's also called standard form. So in this case, general form is ax plus by plus c equals 0. You might also see what's called standard form, where we have ax plus by is equal to c, where the constant term is all by itself. Not particularly useful, but it is another option. You might see a line written that way. And so this is just a sum up of all the types of equations that we've seen here in this video.